Hi, my name is Alex, and we're here with Modos. So I just want to give a quick update on the prototype that we've been working on. And first, I also want to give a thank you to NLnet and NGI Zero for the grant that allowed us to finish the prototype.
As you may already know, our monitor is fully open source. We've already open sourced it on the GitHub, and you can go to the GitHub today to look at our repo. So aside from all the feature updates, which I will cover soon, I've also done a lot of documentation updates. So if you just go to our repo, you will be able to see this README with block diagram and with all the features that we support, and also a very detailed explanation of the driving mechanism that we're using on this monitor. So you can definitely go and check it out, learn how we build it, or if you really want, you can also try to build it yourself just from these source codes. We have two separate repos. One is for the portable e-ink driver that you can port to different boards, embed into different applications, driving different screens. For example, you may use this driver in an e-reader or tablet, or like this in a monitor. And then, if you go to our Modos labs, there is another repo called the glider. The caster is the driver one, and the glider is this monitor. This glider repo hosts the actual hardware design for this monitor, including the PCB, fully open source, and also the enclosure. One limitation that all ink-based devices face is the trade-off between grayscale reproduction and refresh time. If it only needs to display black and white image, it could typically finish within about 100 milliseconds. But if it needs to display full 16-level grayscale, it takes 200 to 300 milliseconds to update the screen, and the process is flashing. What usually is being done is that the screen would have different update modes, allowing the developer or the user to pick the trade-off depending on the scenario. We did the same thing here by offering multiple modes for you to choose from. Let's take a look at them. First coming up is the black and white binary mode. In this mode, you get fast refresh rate and low response time, but the image doesn't have any grayscale. Note that unlike many competitors, we don't have a dial for trading off between the contrast ratio and refresh time. That's because with our pipeline controller design, it always operates at the highest refresh rate possible while maintaining a high contrast ratio. Next up, we have a bare desert mode. This mode builds on top of the binary mode, but adds bare designing to the image. This allows you to see some middle tones at the cost of some jagged edges around the text. Then we have the blue noise desert mode. This is similar to the previous mode, but using a different designing method. It further improves the grayscale reproduction at the expense of more noisy looking text. This mode is also sometimes called the video mode on competitors' devices. Of course, you could use this mode for watching videos up to 60 FPS with our pipeline controller design. Personally, I wouldn't recommend using an ink screen for just watching videos, but the mode is here for you to use. A more common use case for ink monitors would be typing. So we have developed a mode specifically for typing as well. As I mentioned before, there is always a trade-off between grayscale and speed. On one extreme, you have fast binary mode, which doesn't look too good. On the other extreme, you have slow 16-level grayscale mode, which is too slow for typing and the flashing is disturbing. Here, we pick the middle ground for typing, offering the same low latency and non-flashing update as the binary mode, but with full-level grayscale. This allows some anti-aliasing on the text. Finally, we of course have the 16-level grayscale mode as well, but improved. What we have here is actually a hybrid mode. It automatically switches between the binary mode and grayscale mode, so you get the best of both worlds. As you can see, it's in the grayscale mode right now, but as soon as I start scrolling, it switches into the binary mode. Once I stop scrolling, it renders page in grayscale again. This mode is geared towards reading and browsing. When reading, it provides good image quality, but it also achieves fast response time when flipping through pages. The grayscale mode also has an optional desert-enabled mode. The difference is subtle. Some people may like the look, while others may find it disturbing, so it's your choice whether to enable designing or not. These are the modes we have implemented so far.
So we've gone over a few of the different modes that we have. So I think one of the benefits of the display control that we've developed is that it allows us to be able to define different modes for particular use cases. So with the hybrid mode that Wenting showed, that is one mode that we created, and there's other possible modes that could be created depending on the application. Thank you to all of our supporters and everyone who has completed our community survey, pilot program, email conversations, and one-on-ones. And thank you, NLnet, for your support. We're happy to announce that later this year, we'll be launching our crowdfunding campaign on CrowdSupply. We're excited to make available our paper monitor and display board and can't wait to see what we can build together.